Hello and welcome to the Technical Director presentations at FMX 2013. My name is Volker Helzle. I run this course at Film Academy together with my colleagues in research and development. What does a TD do at Film Academy? I think the easiest way is that the students will show you during the next hour. And I would like to encourage everybody who is interested in this course to speak to me after this talk. You can still apply for the fall semester until May 3rd, and in case you're not from Germany, that doesn't matter. You can apply as long as you have good English skills. No German language skills are required. And we're looking for people with a preliminary diploma in computer science or similar. So you should really know how to write code, and you should be interested also in research topics and not only the production aspects of filmmaking. So without further ado, here's a lot of flyers. Go see me after the talk, and now please welcome the technical directors.
Hello guys. Sorry, I'm a little unfamiliar to talking through a microphone, so bear with me. I'm Thomas. I'm an FX TD, and I'm going to give you a small overview of what I'm doing. I call it a taste of effects, shading and rendering, because I did some stuff that involves food somehow. Anyway, short breakdown about me. I studied computer science and media at in Dresden, basically, and then I decided to specialize in visual effects, and I mainly do effects. But I'm also interested in shading, rendering, pipelining, because it's pretty cool to have an overview of everything. So, about my work, I'm starting with the topic marinated herring, because there's a visual effects short called Deep Dance, in which a fish at some point surfaces from a milky fluid, which is viscous, and it's a time-lapse shot. No, time-lapse, sorry, slow-mo. So what were the requirements of the shot? It was not supposed to look like a submarine because the fish actually is only 1 meter long and not 100 meters. And because of its slow-mo, it already feels like pretty big. So I had to solve the problem of making it not looking like a submarine. Yep. And what I did for that was splitting up the simulation into 6 separate sims, because that gives you like more detail. If you do only one simulation, that kind of blurs out lots of drops in detail. And it also makes it better controllable. We'll see that in a moment. And I had to look out for the drops not getting too tiny, because that also would convey a scale that is too big for that fish. It's work in progress, but let's have a look at the first 2 versions. First one was only layout. It's really noisy and all. But as you can see in the split up, the directors wanted me to change one part of the fish at the fin. And it was pretty easy because I only had to re-simulate that part, actually. Yeah, that's my work in progress for Deep Dance. It was done in Realflow, by the way, for anybody who cares. Okay, completely different topic is Destroying a World. For last year's FMX trailer, I guess most of you have seen it. It's a complete short, actually. The trailer was just a part of the short movie. And I got the task from the director, Sasha Gedder, to create several fragmentation systems. One for buildings cracking through the ground, one for buildings collapsing, and one for cracks in the ground, like in an earthquake. Which required me to do, well, manage huge amounts of data, because some shots are really, really heavy, like top shots of a whole city collapsing. And I had to convey a huge scale, because obviously these skyscrapers were really big. What did I do? Once again, I split up the simulation. What you see in this picture is a patch of ground that I had to break up. So I split it up into, I don't know, 15 parts or something, which are all simulated separately, and only interacting parts are simulated together. I slowed things down with like a gravity value of 3 meters per second squared, because that also makes it feel like pretty big. And I added up to 3 layers of secondaries, up to dusty particles, basically. This is also work in progress, but the director did a good job shading it. And what's very specific about this is, about those 2 shots, is that I only created the setup, and the director himself, who's very talented 3ds Max generalist, did the shot himself, which he did pretty good. Oh yeah, there's another one. That one is simulated by me to test the setup. You have like a simulation for the left side of the street and the right side of the street, and then the other block of buildings. As you see, it's all work in progress, but going pretty well. Done in thinking particles, and ravefire. So most of the fragmentation is completely procedural and triggered by helper objects. But some of it, especially for the groundbreaking, is ravefire because the cracks just look more natural that way. But he wanted the Voronoi look for the buildings. So, make it more viscous. Famous feedback line from the director of Wedding Cake. Because the opening shot of the short, I don't know, it's an animated marriage, it was screened already. It's called an animated marriage. Involves dough getting steered. And the problem of that is that dough is non-Newtonian, which means it behaves different than any standard fluid simulation. And we needed artistic control. So what I did for that was, I got the idea of like, I could use the spoon as a heater because non-Newtonian means that the viscosity changes when when the fluid is moved. And I could control the viscosity via the temperature, which is in theory pretty cool, but Realflow doesn't allow you to do that. But the creators of Realflow actually created a free plugin to make that possible. So I didn't have to code it. And credit also goes to David Kirchner, who's a diploma technical director, because he did some pushing and poking in Houdini to make it look really, really like the director wanted it. So this is the final result. Yeah, we're pretty happy with that. Nicely shaded by Markus Kranzler. How to shade a girl in 90 seconds. Yeah, there's a diploma visual effects movie called How to Get a Girl in 90 Seconds, which is the title that is way too long. But it's a cool project, which required me to shade a city, a whole city, or at least a block, and to render 27 shots in 2 weeks. We had a pretty tight schedule because the director got his diploma for now with a temporary version, and we're finishing the movie in summer. So we had to get everything done, but we now have time to polish it, so it's completely work in progress. One thing was that he wanted only one key light, which is the sun, and global illumination for the lighting, which is pretty heavy if you have to render a city. So what did we do? First thing, the director, Johannes Peter, created some really good base shaders, and I added some complexity to them. This is only, I don't know, one shader, or the shader for one building, or piece of a building. It was quite a lot of shaders that I added like dirt maps to, and complexity in like noise structures and stuff, which was good enough at that point for the shading point of view, or from the shading point of view. And we used 3ds Max's XREF system, which works pretty well for static objects if you don't have to modify them, and RP Manager, which is a plugin for 3ds Max, because 3ds Max up to version 2013 does not have a render layer system, which is crap. But RP Manager provides that and is pretty good in that. So that was a game saver, definitely. And one more thing that helped us getting it done in only 2 weeks was baking the GI for the shots without animation, because the two hero characters are filmed, they're real people. And we only had little animation in most of the shots, so we were able to bake the GI, which is pretty quick, and thereby disable flickering, basically. So the final renderings have GI and are totally flicker-free. Yes, I have a few shots. There is the lollipop, part of the title of this presentation. Yeah. All 9 of the shots were stereo, by the way, which was not really an issue because the director did a really good stereo layout, and I only had to render things twice with different cameras, so not really a problem. Yeah, last topic, the Sandman. Last year I got a scholarship, which is called Karl Steinbuch Stipendium from the MFG, which is kind of a fund making scholarships for students. And I applied with an idea from last year's FMX actually, because Kai Stavginski from Double Negative built a sand simulation based on the GPU for John Carter of Mars, and that idea inspired me to do the same thing, basically. What I want to do is fast simulations of grains in all kinds, because they all behave the same. I want a slim plugin, because I might want to build a plugin for another application afterwards. What I'm currently doing is 3ds Max. And I want a portable cache format, because it's cool if you sim in one application and then render in another one, that you can read the caches, obviously. What am I doing currently? I'm working on a rigid body solver with high friction spring forces, because that conveys the sand behavior. I'm caching using Disney's OpenPart.io format. Don't know whether any of you know that, but it's pretty great, because it enables particle handling in a very easy way, and also saves out Houdini and Maya caches, which is pretty good, because you simulate in Max and then you have Maya and Houdini caches. Could have taken Alembic, but I like Part.io, so that part of the project is already finished. And I have a basic 3ds Max plugin, which I have to polish. It's based on legacy particle systems. Don't know whether anybody of you knows 3ds Max. But anyway, that provides a good UI and programming API to implement the rigid body solver, and that's what I'm doing currently. I don't have anything to show up, but it's a pretty cool project, and I'm going to finish it until beginning of November. So that's all from my point. Thank you for the attention.
So yeah, if anyone wants to take notes, I don't want to rush over that. Yeah, my name is Markus Kranzler. I'm also TD in the 4th year, so we all have about 1 year already behind us. I'm going to talk about Roland Safari, which some of you might have seen somewhere. Lighting and rendering wedding cake. So like he mentioned, the dough, for instance. And another project that's currently running, or just started running, where I did a lot of different things, so I just called it TDing. So yeah, my background, I have a degree in math and computer science. And for my thesis, I used, or I implemented spherical harmonics and implemented them into a kind of a shading tool for RenderMan inside of Maya. So that was already with the aim to become a TD later on. And yeah, I'm specializing in lighting and shading, rendering, so kind of the end of the pipeline. But I also did some effects because they are interesting, they look cool, as well as pipelining, which I will also cover with the ongoing project. So the first thing, Roland Safari, some might know it as Kugeltiere, which is the trailer for ITFS and FMX this year. Yeah, the challenge about that was, since it plays in a savanna, there's a lot of dust and sand and dirt and stuff, so yeah, someone needs to simulate all of that. Yeah, the animation was done in Maya by 3 really talented directors and animators, but I wanted to use Houdini because that was kind of the challenge that I yeah, obliged myself for, that I wanted to learn Houdini for a long time, but I never really had a task to really tackle. So I said, okay, here I start doing effects and I want to learn Houdini, so I'm going to be your Houdini artist. And that was the first time, so I had a bit of problems, of course, but there are so great people at the Film Academy that always are happy to help you, so whenever you learn something new, there's probably someone who already did it and helps you. So for the dust effects for the Roland Safari, I tried to figure out where the animals actually stepped on the ground. So there you can see all the steps that they already took. And I used those areas as emitters. And in this video, you can see that instead of using a very large voxel grid that where the animals run around in, and you only have a very sparse level of detail, I zeroed out the animation of the cheetah, and everything is related to its animation, and the voxel grid then stands in the center point of the world coordinate system, and everything moves underneath it. So kind of the gazelle is now running backwards and the ground is sliding under the animals. So therefore I could use a much higher resolution for the voxel grid, and later on then I just moved the voxel grid with the whole cheetah. And there you can see how the playplast kind of looked, and also a rendered version. So yeah, some might have seen it. So yeah, the next project was Wedding Cake. Like Thomas said, it's a diploma project. And there I was the lead lighting TD. I'm emphasizing the lead not because I have a big ego, but because it involved a lot more work than just doing lighting on actual shots. So of course that was a big part, but it also included stuff like optimizing processes and workflows, documenting stuff, so whenever someone new came in, had some sort of guideline, as well as the review sessions with the director, because she wasn't really familiar with 3D animation. So the whole process of rendering and lighting was kind of new to her. So of course all the feedback that we got was kind of complicated, because she used terms that we thought we knew what she meant, but actually she meant something different. So that's, of course, it always happens that there's some miscommunications, and so we figured out, okay, what's stuff that she usually has to review and give feedback on because she would like to have it changed or whatever. So yeah, we documented stuff like that. So we had a list to go through. I also had to delegate the tasks for the lighting artists or the lighting TDs. Like, okay, you take over that shot, and yeah, you have to do this. And of course, support, because a lot of the people that came and went didn't use Houdini before, since it's not that often used for students. Usually people have a background in Max or Maya, so Houdini is often something completely different. And this is kind of only to show you how my desktop usually looked. So there's not only 3D applications, there's a lot of text stuff going on, so a lot of lists we had to go through. We have a wiki at the Film Academy, so I used that as a hub where I could write in feedback comments, and so everyone could just look up, okay, this shot was already worked on and those were the comments, so I have to do those tasks next, and also coding and whatever, and of course rendering. And here you see some of the light setups for one shot. So all those wireframe things were actual light sources. Since it's a very artistic approach, we lit almost everything with only a very few key lights and a lot of different rim lights that followed the characters. and the whole setup was done by a former fellow student who already graduated this year, and I think he's in the crowd. Nico. Yay! So yeah, and there, this is one of the shots, how they look now. Just to give you a little sneak peek. Not sure if anyone has already seen it. I think on Friday there's a screening, Friday morning, maybe. Yeah, so next thing is the present. So this is completely a work in progress. I just started on it, and so far I did mainly pipelining, which meant that I programmed shell scripts to help artists that come onto the show, that usually you would have to set up some stuff like environment variables, install maybe something, and copy maybe scripts from one folder into a local folder. So since that's very tedious, I thought, okay, I want to manage everything like that with a script. So there is this Maya batch file. So when an artist just clicks on that one instead of the regular Maya shortcut on the desktop, everything will be set, and when he closes it, everything will be reset again, so it doesn't really mess up the whole PC of the artist. Yeah, I wrote quite a few Mel scripts so far that initialize Maya with also some variables and functions and stuff, and they take care, for instance, of naming conventions, because usually what I often forget is when you save a file, you maybe forget to increase the version number, or maybe you forget to put it behind or in the name some user short name, so anyone can recognize, okay, that's the last artist that worked on that file, so if something changed, I have to go to him. So that's completely managed by the scripts. So you just type in any name, and then it automatically figures out, okay, this artist worked on it, and there's already a version 15, so I save it as a version 16, for instance, stuff like that. And also referencing files is something that often happens, like rigs or whatever. So I have my own little script that when you're in Maya and you say, okay, I'm done, this version should be used from now on as a reference. There's a separate folder where everything gets copied into, and then this file usually doesn't change. It keeps its name. There's no version number or anything. It's just one file, and it will only be overwritten, and in a separate folder you have all your backups. And a lot of Python scripting as well, like a plugin node where scene information is stored. So it's easier to read this information out. Also, it's human readable, as you can maybe see on the lower right, that yeah, you can see who worked on it and which version number it is. And I did also some Slim and Tickle scripting. Not sure if anyone ever used RenderMan Studio. There's a shading authoring tool called Slim, and in there, if you have a shader, for instance, we have this couch that you can see in the Maya viewport a bit. It has several separate objects, but basically they are all made of only two different materials. So it's either a pillow or it's just wood. But if you have several objects with different textures and you would apply different shaders, and then you say, oh, actually I want a bit more specular on all of the wood, you would have to change maybe 20 shaders. So instead of that, I have a script that figures out this object has a texture that is unique, but you only use one shader, and the texture will be substituted at render time with the actual texture name of that specific object. So you only have two shaders, and you just change whatever you want, and then all the objects that have that shader will change as well. And there are some early render tests, so this is all still work in progress, of the main character, or one of the two main characters, a little dog and a little boy. But no worries, he's not deadly sick. It's just that the grooming for him is not done yet. And, oh, doesn't work. Yeah, this is also an animation test, and we tried out with some subsurface scattering, how it will look, to see how the wrinkles will maybe become more or less obvious when there's subsurface scattering going on. So yeah, that's just a short preview for the animator. And this is a short walk cycle for the dog, where we wanted to see how the fur behaves on the animated dog. But yeah, like I said, not finished at all. And a little outlook for some R&D work that I do. There are two pretty cool open source software projects. One is called SEXpert from Disney, and the other one is OpenVDB. It's a volume data tool set from DreamWorks. And basically, SEXpert is an expression language, kind of a package. And for those who have used Houdini before, that's something, yeah, you don't really enjoy much because it's built into Houdini. An expression language gives you the ability that, for instance, if you want to translate something but follow a mathematical curve, you can just use with the expression an arithmetic expression. So instead of typing in and keyframing every position, you just say, I want to do the translate in the X direction by frame number to the power of 3. And then you get a whole animation. You only do one quick function call and that's it. So, and you can do that, use that for Maya, and the idea behind the R&D project is to have the ability to use an expression language to generate and change and animate a volume. So you just type in any mathematical 2D or 3D function, and then you can say, write out a volume based on that. And so that's pretty useful probably for visualization stuff, like physical based stuff, and maybe also animation, very artistically controllable. So yeah, and that's what I'm doing right now. So yeah, that wraps it up so far. Thank you very much, and later on come and ask questions.
So yeah, hi, I'm Martin Minzel, and I'm doing mostly pipeline stuff, and what I will present to you now is like the stuff I did in the last 6 months, which is basically the pipeline tool, which I'll show some compositing tools I did for a diploma short, and as a last thing, I'll show you some R&D, an R&D project which I did for the exams. So first thing is the tool called Pipeline, which is basically a project which I do for quite a long time now. I paused it for 1 year and relaunched it in September, so everything you will see in an instant is done in the last 6 months. It's basically an asset management and project management tool, which should be able to schedule, track, and organize a visual effects production or an animation production, and should take care of version control and should make handovers easier from one department to the other. So the whole concept behind that is that the whole graphical user interface is node-based, so that you plan your production like in Nuke and not in a schedule like most producers are used to. And it should be cross-platform so that you can use it in a Linux or in a Windows environment as well. So these are some screenshots I took from the actual tool now. What you see is now the admin graph, which is like the producer's view or the pipeline TD's view of the project, which you can see now is like every task is a node, and there are even grouped tasks, which is like a shot or something. And you can add to these shots like different tasks, and you can easily see dependencies. You can easily track how many people are working on one shot, who is working when, and you can see by looking at the schedule down below. And the artist then only sees this graph, which is basically a list of tasks on the left. And if he clicks on one of those, he'll get like all dependencies in the middle and a closer description of the task he selected in the node graph in the middle, which shows him like the dependencies who will work for this actual tasks, who works on the dependencies, and who does he work for. So this is the graph of people, as you see from P. Quichon is working on a model, which is then used in animation, and this will be given to Light, so to me, basically. And that is the other view the artists have. So that is like a schedule where they can see on which day each task is planned for the artist, and the artist can then launch the software out of that schedule, and the scene will be set up, and the latest version will be loaded, and yeah, it should all work fine. Yeah. So now, what I wanted to present is some compositing tools I did. These are basically like, I'll just say quickly, it's 4 tools I'm going to present. This is the Harald read node, the Harald Z-slice, the Harald ID keyer, and the Harald write node, which is basically the Harald read node and the Harald write node are just some pipeline nodes which make it easier to load in all the 3D renderings or to write out all the final images. And the Harald Z-slice and the ID keyer are basically tools to make it easier to pick certain pieces in the images. So the Harald read node is pre-comps automatically all the AOVs which are rendered out of the 3D, and all the technical passes are passed into the channels in Nuke, and you have a debug function where you can directly see each pass and which pass is missing, and it will load in the latest version of every shot. If you don't want that, you can even change the version of that and stuff like that. So this is like how the interface looks like. You can do all the color corrections of each AOV inside this node, so you don't have any issues by loading every single rendering and having to apply a color correction or something, because it's all done for you. Then the next thing is the ID keyer, which is basically a mask of each object, and you can you'll have a handle which you move around the viewport, and on each point where you move the handle, this object will be picked, and you can even freeze the frame on where you pick, so that if the camera moves, the object will be still picked after 100 frames or whatever. The Harald Z-slice is basically a tool which grabs the current position of the handle and takes the depth, which is at this point, and creates a sphere around it, and selects everything which is around in a radius, which is given by the X and Z handle. So the X and Z radius is given by the width of the handle, and the Y radius is given by the height of the handle. So you see that box basically, and if you make that bigger, the sphere is going to be bigger, and if you make it smaller, it's going to be smaller, and you can decide how big the fall off will be, where will it start, and stuff like that, and you can even freeze that, so that camera movements shouldn't be a problem with that. The Harald Bright node is just a pipeline thing again, which is basically just giving the artist only the controls. If he wants to render a previs, if it should be the final image, if yes, then the grain will be applied, it will be set on the right resolution, and it will go to the right folder. Each rendering will go to a separate folder with a version number and a render log, which says like who rendered it out, how many frames, and which nuke script was rendered off. So the last thing is the R&D work I started, which is the paper sketch implementation. This is what every technical director has to do in order to get the diploma. So I chose as a subject the paper three-dimensional proxies for hand-drawn animation by Jane. It's a paper to generate three-dimensional proxies, which are locators, or even a mesh or an FK rig, from an input, which is a hand-drawn animation, basically. And the approach in the paper is that you basically have a mocap clip, which is a little bit similar to what you have in your hand-drawn animation, and so you pick basically the closest point in depth to that to the mocap clip. But what is the difficult thing with that is that you have quite a hard time to put your heuristics in. And so I came up with another approach, which is basically like if I have my reference rig, which is the pink one, and I have my mocap data applied to that, then I'll still compare that to the wait again. So if you have your reference rig over there, then you create a sphere around each joint and look from the camera point. You shoot a ray to that position of your hand-drawn animation, and then you try to get an intersection between the ray and the sphere you created, because the sphere is the radius where the joint can be moved to, and so you can actually get the depth of the joint where it can be. This can be 2 points, 1 point, or 0 points. 0 points is just like we're making the sphere bigger until we hit the sphere. 1 point is perfect because we just have 1 point to go. If we have 2 points, I can start my heuristics. And so this is like a first test. And this was the animation. This one is basically, as you see, it's jittery a little bit, but after filtering, which I show in a couple of seconds there. On the right is the filtered version, on the left is the still jittering one. The result is way better, as you see. I hope you see this. Yeah, and now in big, the filtered result. This rig is basically a transformed rig, so there's no rotations at all in there. Every joint is moved to the position it should be. So the next step is to get a rotation rig out of that rig. And I did that with a couple of constraints. So I duplicated the transformed rig and applied constraints from the transform rig to the rotation rig to get the rotations of the joints. And what you see on the right is now the motion prior, which is basically the mocap data, which I hand animated fairly roughly. It took like 10 minutes to do that. So as you can now see it in comparison, like how it moves from the motion prior to the rotation rig. So, and in 2 iterations, I'll show just a really rough-skinned model. You will see the constraints are working quite okay, but there's still a little bit flipping of the constraints, which I still have to fix. But yeah, that's currently the work in progress. And yeah, that's for me. I'll give over to.
Hi there, my name is Christoph Westphal. Before I went to the academy, I studied computer science in connection with media and communication and worked in visualization for some time. And today I'm gonna talk about 3 projects I worked on at the Film Academy. This will be Roll in Wild and Deep Dance, where I did rigging, and Deep Dance and Wedding Cake, where I also did some fluids. So we start with Roll in Wild. So I did some more stuff there, also tried some compositing and scripting in connection with the rigging. Today I will only cover the rigging part really briefly. So this is the rig I built for Roll in Wild. It's basically an adjustable generic fat animal rig. What makes it differ from ordinary quadruped rig is, as you can see, it don't really has a spine. That was because to animate nice walk cycles with these balloony animals, the movement of the shoulder was quite important. So we needed to translate the legs alongside the body to make it somehow interesting. The rig basically has everything what a good rig needs. We have IK, we have FK, we have space switching for the controllers, and the most part of the facial animation was done using blend shapes, but for the rest of the body of the animal, we didn't need any corrective blend shapes at all. It worked all really nice with this kind of bone setup. I also wrote some scripts to support the animators, but these were just basic. You could save poses, pose mirroring, and all these aligning of different IK states. And yes, that's what we did. One part of the rig I like to show further. So I built an IK setup, which was working down from the shoulder to the leg. So basically, you just have let's say 3 joints in an ordinary arm rig. But I found if I had to animate this, I would find it to be annoying to move the shoulder all the time with the leg. So I tried to implement something which is doing this all in one move, so that you can control the whole leg from the shoulder down with the IK control. So and this was the blendable IK shoulder. Yes, it was blendable with the FK, as you can see here. And the thing was, what it's doing here, there was one additional parameter, because when you have the shoulder, the upper arm and the lower arm, and you move it with one controller, you need something to define the end result of the leg. So I had this one single parameter which enabled me to bend between the upper and the lower arm, or between the upper leg and the shoulder. By blending it with the FK control, it felt like somewhere you can feel that it takes some that it felt kind of realistic to move the legs with this IK stuff. So I liked it. It worked nice, and it was even used in the show. Most animators use FK, but it was used. In the end, the rig was applied to 3 animals in the show because I had another really talented guy at the academy who wanted to do some rigging for the role in Safari as well. So it was used without any changes on the gazelle and the zebra, but there were some changes for the crocodile since the legs working a little bit different, and it did not need all this kind of motion that the gazelle and the zebra needed. Okay. So now we're coming to deep dance. There are some rigging in XSI and some fluids in Houdini. What I built there is, so here's, deep dance is basically, it's in a really, it's in a deep water movie about a squid who is in kind of a fight with this big fish. And I rigged this one. And I had some problems in XSI using the spline IK, which was built in. So I built my own in ice, which worked pretty well. So the main problem with the built-in spline IK was that I did not have any access to the lookouts of all the bones in the chain. Here we have all these controls here for rotation, translation, and of course you could put the rig on a spline because all the animatic was done by moving the fish along a spline. So I made sure that the rig is capable of doing this. Furthermore, the director asked me if I can build something more procedural to add some movement to the fish without having to animate it. So I created this wave compound in ice as well. And it's basically just a sinus curve you can separately apply to the X, Y, and Z axis. You can offset them. Then there's this curve where you can say how much influence of the curve should be from the tip to the tail of the fish. And by blending all these together, it was possible to create some nice movement of the fish without animating anything. Of course, what was able to animate on top of this approach as well, as you can see here. It's still working. So there's only one short jump in this animation. I guess it's because it's just a loop of 100 frames. So, and we had a lot of spring solver in the for the fins and the gills and the bartles. Okay. And of course, this wave component could also be used on the spline where the fish was animated on. So you can take any spline, drop it there, and use all the controls to make some movement. Okay. Now we come to the fluid part, which is totally work in progress right now. So inside the movie there is a kind of a dream sequence of the predator where two of these fishes are swimming into another, and the director told me he wants to have something which looks like milk and milky fluid, and they're melting into another, and the effect should evolve over time. So right now it's about 9 shots, which is changing every day. So what I did first, I tried some look depth. I just took the fishes, and here I tried to utilize custom velocity fields to make the water move alongside the body. They liked it, but they did not like that there's gravity inside, and I did not like that we are losing all the detail in the head, since I just took the old fish as an emitter, but it was quite fast. I was using flip fluids, and for the first, I guess the first 4 seconds of such a simulation were below 1 hour, really. This was nice. I love Houdini for this. Then I tried some different approach where I did not constrain the spreading of the fluid. So, because I read somewhere for fluid it's always better not to constrain it, just give some start conditions. And so I tried this. And I like the look pretty much, but I think I can only use it in the end of the shot where everything is going crazy. And again, I had the problem that there's no detail in the head. So I tried to use a noise field as an emitter. This was the test for this. So we have just start conditions for the velocity of the fluid, and I just want to see if it works. So right now it's just popping out, but what I like more is that we now can actually see the fish. So right now there's no displacement, no detail in the head, so it will look gorgeous in the end. But it's just a test for me. So what I did not like with this test was that now we have an emitter which kind of, in a random fashion, is emitting fluid, but it still seems like it's moving on top of the surface of the fish, and they wanted them to flow into another. They should become the milk. So what I'm working on right now, so I started to work on some actual shots for this now. I created a paintable emitter setup, which you can see here, and what it's doing is, so with the red color you can basically paint just what is visible in the shot, because everything else will be deleted. And with the green channel, so where everything is yellow, you can define an area where this noise map will be applied. And this will also be used, and everything which is painted green will be used for displacement as well, so just to fake some fluid moving on the body. And with the blue channel you can then actually define the areas where fluid should be emitted from. So what you can see in the third one, there's already the displaced version. No, it's coming. I'm just taking the points of this mesh. I have to make it quite dense, so I tried with scattering, but I found it's better to just use the points of the mesh, and I use these points in the meshing of the fluid, so that I have a fluid representation of the fish, so I won't use the geometry which I get via Alembic. I will solve everything as a simulation. I did not manage to make a shot where the fluid is in, but I did some meshing of the surface. It's quite low res, but I guess it's working quite nice. It's really fast, and I also can really quickly, in real time, as long as I take a low resolution version, I can previs where the water will be on the fish. So it saves me a lot of time and gives a lot of artistic control, so I can just sit down with the director and ask him how large should all these fluid islands be. You can play around with different noises, and you don't have to wait all the time when you change a small parameter. So this is what I'm in deep dance right now. And like everyone at the academy, I wanted to have a shot in wedding cake. So I took there's a funny short shot inside, and I wanted to do this. It's basically the death of the small dog in the movie. I just show you this was my first try for this animation. I liked it because the tail still stands after he dropped his foot, but the director told me that actually they wanted something else. They wanted a kind of really a cartoony splash, something which looked like a conic thing. Because in the following shots, there's not that much fluid laying around and sticking on the ground, and also in the next shot the female actor of the film will be hit by one of the splashes from this stuff. So I created something in Houdini really simple. I just took this splash shape where I dropped a ball inside with a really high... okay, I will hurry up. Where I just dropped this ball, and through the valleys of this shape I could control where the splashes should go, and this way I could make sure to hit Mary in the face in the next shot. There was some. She liked the shape, but there were some problems for some frames that it. As you can see, the second frame, for example, it looks like a muffin. So I fixed this just modeling-wise, so because I did not want to reanimate over and over again. So I'm gonna show you just the final stuff. Unfortunately, there's something missing in the next shot where you can actually judge yourself if it's working with the proper speed and stuff, because we did everything. Speed, faster, slower, it should be fast, should stay in the air at the end, and it was crazy. It wasn't not a simulation anymore. It's you could have modeled this. It's only 8 frames. Okay, thank you for coming and listening, and hope you're gonna enjoy your stay.
Yeah, that was quite packed till the end, like almost 1 full hour. I think in respect to the next talk, if you have questions, please meet the TDs outside, or if you have questions to me, because we need to prepare the next session. Thank you.